In this example, we're going to calculate an expected value, and typically with these problems, a lottery is a good example of how to find the expected value. If you look on the left-hand column, we have cash prizes. On the first row, it says the word grand prize. They're going to give us that number here in Part A, as we'll see. And on the right-hand side is the probability of winning that prize. So if the grand prize is $13 million, find and interpret the expected cash prize. And if a ticket costs $1, what is your expected profit from one ticket, which is a follow-up question. So the first thing, the expected cash prize. I'm going to show you this in Excel this time, and I'll show you the calculator, the quick steps to do it there as well. What makes Excel fast for this is that you click right here and you can do open in Excel. And what that does is it will download an Excel file down here to the bottom of your problem if you've never done this before. Click on that and it'll open up Excel. Alright, so the file is open in Excel. I'm going to have to click Enable Editing here. And what you do is you simply multiply everything in row A times everything in column A by everything in column B. So in Excel, I'm going to say equals, and then I'm going to move over here and say the cash prize of 13 million times that probability. Notice it's turned the probability into scientific notation because the decimal is so tiny. And then the cool thing is with Excel, if you put your cursor right over the corner there till it turns into a black plus and you double click, it will fill out the formula the rest of the way down. And if we go back and review what expected value or the mean of distribution like this is, you just take the sum of those products. So I'm going to type the words equals sum, and then I highlight the columns above it. There's one way to do it with my mouse. And then close parentheses and press enter. So my expected value is 0.315. Now I'm going to change that to dollars because this is a dollars problem. If you click that little dollar symbol, it will round it for you. So now we can go back over to the problem, and that's going to round that up to 32 cents. So let's go back over to the problem now. So as you can see there, I put in 32 cents, and that was the correct answer. And the correct interpretation of that expected cash prize is, on average, you will win 32 cents per lottery ticket is the correct answer, not profit, because now what did you have to pay to participate in this lottery? You had to pay $1. So the expected profit from one $1 ticket is that amount back over here in Excel. That cost us $1. So we take, just say equals 32 cents minus $1, and we get, and it puts parentheses around it, which means negative in accounting terms. So it's negative 68 cents. So if we go back over here and we'll put in negative 0.68. Now, to the nearest million, how much should the grand prize be so that you can expect a profit? All right, now I'm going to use some trickery here in Excel to show you how to do this. It's not really trickery. It's a really cool tool that you may know about in Excel or you may not know about. So let's go take a look. All right, so here's the special button click in Excel that does this for you. This was our expected winnings, and then our profit was negative. We want to make that profit be at least 0. So I want the cell where negative 68 cents is to become at least 0 or higher. So if you click on data here, menu at the top, and you go over to what if analysis, you can go down and do goal seek. And what goal seek does is says, look, I want to set that value in that cell C11, the negative 68 cents, I want that to be 0. I want to at least break even or make more. And I want to do that by changing this cell right here, the $13 million. And you press OK, and it actually does the algebra for you and tells you that the number is $89,633,683.76. Now, that's the way you use the fancy Excel click. Now let me show you what the math teacher in me wants you to know, which is how do you actually do this using the steps of math. So let me explain how you do this algebraically. If you go back and think about what we did there in Excel, we took this number here times its probability. So we want to know what that number is, and in algebra we use x for that thing. That times that big long decimal 0.000, a bunch of zeros, 893, plus 200,000 times 000, a bunch of zeros, 35, and then 10,000 times a bunch of zeros, 1769, plus 100, and the next probability. We're going to keep multiplying those two things and adding them together. We want that to add up to 1. So essentially, if we set this up as an algebra problem, we can take and put all of those things on one side and 1 on the other. So if we subtract all of these multiplications here, and then from both sides, and subtract that over here, then we can find an equation that is x times that probability of grand prize, and we can divide both sides by the probability of the grand prize, and we will get the answer that we want. So let me go show you in Excel what I mean. So I'm going to write a formula here that says equals 1, which is my winnings that I want so I can break even, minus the sum of all the numbers except the first one. Okay. We're going to take all of these numbers down to the end of that row. Alright. Alright, that's the expected value without the top prize. Now what I need to do is take that, and I'm going to modify my formula here and say I'm going to divide all of that by the probability of winning the grand prize. So if I go to the end of my formula here, I put parentheses around it so we can follow order of operations properly. I'm going to move over here and I'm going to divide by that probability right there. You see we get the same number we got before. Now my math lab wants to know this number to the nearest million, and so if you look here, the nearest million would be to go to 89. It's 89.6 million. So we need to round that up to 90 million. So our answer will be 90 million. Let me go back over to my problem and I'll put it in. So here we are, 90, and 3 zeros, and then 3 more zeros. And so that's our correct answer. Now, does the size of the grand prize affect your chance of winning? No, right? Because your chances of winning any amount of money are based on the probabilities, not on the prizes. All right, so it's determined by the properties of the lottery, not the payouts. All right, so the correct choice there is C. Now let me show you really quickly the calculator and how you would do that. I'm going to go ahead and set up all these things in the calculator. Go here to Stat, and I've entered all, press Enter, and you would enter all your numbers. I've already entered them to save time. Then you press Stat, Calc, and we're going to do 1 bar stats. And I'm going to do second L1, comma, second L2. So going back up to part A here, you can see when I calculate that I had one data entry error. I get the same thing here with my X bar, 0.3156, which rounds up to 32 cents. So to do this on the calculator, what we need to do is go back into our table, and we're going to delete that first row, and we're going to calculate the expected value without it. So you just move to that 13 million, delete it, and it removes it from the table, shifts everything up, and move over and delete that probability. So we're going to get out of there, second, quit. In our case, it was Stat, Calc, 1 bar stats, L1, comma, L2. So now we have an X bar. So this X bar is the sum of all of these numbers less the grand prize, which is what we just did in Excel. And if you recall what we did in Excel, we said we want that number to be, take that $1 minus that expected winnings of 20 cents, and then divide that by that probability. So I'm going to clear out here. Now notice X bar is the coefficient I want. You can write out the numbers if you want. I'm going to show you a little trick here on your calculator. You can actually get X bar. So I'm going to write parentheses 1 minus, and if you press bars and then go down to the option for statistics, you can say, which variable did you want? Oh, I wanted X bar. And it'll take the value for X bar that's stored in the calculator right now. And we're going to close parentheses, and we're going to divide by that probability. So that was 0.00000000893. And when we do that, you see I get the same number, 89.6 million, which rounds up to 90 million. So I hope this video helps you to see how to do this, and hopefully you can understand that algebra behind that step. If you have any questions, let me know.